Air Canada's chatbot once hallucinated a refund policy. A passenger believed the false policy generated by chatbot. The airline refused to pay, so he took them to court and won. Air Canada's defense? Don't blame us. Blame the bot. The court rejected the defense. Here's the scary part. Before launch, someone asked that bot a question, got a good answer, and said, "Ship it." They tried it once. That's not a test. So, we need a proper plan to evaluate the RAG chatbot. It's called an eval suite. So let's build one for our own airline, Sky High Airlines. We built a support chatbot. Passengers ask it things like, "How much does it cost to bring my cat?" And it answers from our policy documents, baggage rules, refund rules, pet rules. It's a RAG chatbot, so it has two parts. The retriever searches the documents and pulls out the parts that look useful. The generator, the language model, reads those parts and writes the answer. So when the response is bad, who broke it? Maybe the retriever grabbed the baggage policy instead of the pet policy, and the generator did a perfect job with the wrong document. Or maybe the retriever found exactly the right paragraph, and the generator ignored it and hallucinated. Two different problems, two different fixes. But from the outside, both look the same. Bad answer. That's why you need a set of tests that checks the system at different levels. Level 1. The components. We test them one at a time. First component, the retriever. Here we test whether the retriever pulls the right documents for the query. You're the AI engineer at Sky High. Nobody hands you a test set, you build it yourself. So you sit down with the policies and write out 50 questions passengers would actually ask. You can let an AI draft them, but then you read every single one by hand. Here's one of them. How much to bring my cat? We'll follow this question all the way through. Now the policies. They don't sit inside the bot as a whole. They're cut into paragraph-sized pieces, chunks. Our 3 policies has 400 chunks. For each question, you find the chunk that contains the answer. For the cat question, it's this one. Cats under 80 kilograms may travel in the cabin. Fee, $95. You do this for all 50 questions. Now you have your golden set. 50 questions and the exact chunks that should answer them. Now let's test the retriever. Give it a question, it searches all 400 chunks and returns its top 5. Just 5 out of 400. So now we check 2 things. First, recall. Did it find the right chunk? If the $95 paragraph is one of those 5, great. The model has the information it needs, but if that paragraph isn't there, the model can't answer correctly. It can't use information it never received. Let's say that across our 50 questions, recall is 0.76. That means the right chunk was found for about 76% of the questions. For the other 24%, the retriever failed before the model even got a chance. Second, precision. We know it returned 5 chunks, but how many of those 5 were actually useful? Imagine the $95 paragraph is there, along with 4 paragraphs about oversized golf bags. The retriever found the answer, but it also brought back a lot of junk. Across our 50 questions, precision is 0.31, so most of the chunks we're giving the model aren't actually useful, and that's a problem. Because more useless text means more tokens, more cost, and more wrong answers. And here's the nice part. Because we already marked the correct chunks ourselves, we don't need a human to judge every answer. A simple program compares the chunks. The retriever returned with our golden set and calculates the score. Fast, cheap, and the same test can be run every time. Now let's test the generator, but this time we don't let it retrieve anything. We give it the correct chunks directly. Why? Because now the retriever is out of the picture. If the answer is bad, we know the generator is the problem. We ask 2 questions. First, faithfulness. Did the answer stay within the information we gave it? We give the bot the pet policy. It says, cats fly for $95. Also, pets fly free on Tuesdays. The policy never said anything about free Tuesdays. The bot made that up. That's a faithfulness problem. Second, answer relevance. Did the answer actually answer the question? The passenger asks, how much to bring my cat? The bot gives a long, accurate summary of the entire pet policy, carrier sizes, breed rules, vaccination forms. Everything it says is true, but it never tells the passenger the price. That's an answer relevance problem. Now we have a different problem. For retrieval, we had an answer key. We knew exactly which chunk was the right one, but now the AI is writing the answer itself, and there's no single correct way to say something. For example, your cat costs $95, or bringing your cat costs $95. Both answers are correct. So instead of comparing the answer to one perfect answer, we use another language model to grade it. That's called LLM-as-judge. We give the judge the question, the context, the AI's answer, and a clear grading guide. Then it scores the response. This works well for things like faithfulness and relevance. But there are trade-offs. It costs money, it takes time, and the scores can be a little noisy. There's also one big problem. Judges often prefer answers that are long and sound confident, but a confident answer can still contain made-up facts, so your grading guide needs to be strict. So quick recap for level 1, components. Retriever, we test it with recall. Did it find the right chunk? And precision, were the chunks it found actually useful? Generator, we test faithfulness. Did it stick to the context? And answer relevance. Did it actually answer the question? Test each part separately, and you know exactly where the RAG system is failing. So far, we've tested the retriever and generator separately. Now let's put them back together, and this time, we test the whole pipeline. We still use the same 50 questions from our golden set, but we don't give the system the correct chunks. Instead, we let the RAG system run normally. Question, retriever, policy chunks, generator, answer. Now we can evaluate the entire pipeline. This is where we use something called the RAG triad. We ask 3 questions. First, context relevance. For the question, how much does it cost to bring my cat? Did the retriever bring back policy chunks that are actually useful for answering the question? Second, faithfulness. Did the AI-generated answer stay within the information in those retrieved chunks? Third, answer relevance. Did the AI-generated answer actually answer the passenger's question? You might be thinking, wait, didn't we already test faithfulness and answer relevance? Yes, but this time it's different. In level 1, we gave the generator the correct chunks directly from our golden set. So we were testing, can the generator answer correctly when we know it has the right information? Here, we use the same questions from the golden set, but we don't give the correct chunks to the generator. We let the retriever find the chunks itself. So now we're testing, can the entire RAG pipeline find the right information and use it correctly? Pipeline eval equals reality measurement. In level 1, we gave the generator golden chunks and asked, if retrieval were perfect, how good is the generator? But in production, retrieval isn't perfect. The retriever can return noise, incomplete chunks, or miss the answer entirely. Level 1, test each component separately. Level 2, test what happens when those components work together. That tells us whether the problem is in one component, or in the way the whole RAG system works together. So far, we've tested how the RAG system works, the retriever, the generator, the pipeline. But the passenger doesn't care about any of that. They care about one thing. Did the chatbot give me a useful answer? So now, we test the application. Let's use our same question. How much does it cost to bring my cat? The chatbot says, it costs $95. Okay, but is that actually a good answer? We check a few things. First, correctness. Is the answer actually right? If the policy says $95, the chatbot should say $95, not $75, not $120, $95. Second, completeness. Did the chatbot give the passenger everything they need? Imagine the policy also says, the cat must fit inside a carrier that goes under the seat. If the chatbot only says it costs $95, the answer is correct, but it's not complete. The passenger could arrive at the airport with a carrier that's too big. Third, style. Does the answer sound like a good airline employee? Compare these. Bringing your cat in the cabin costs $95 versus, as per the applicable policy, the aforementioned feline transportation fee is $95. Same information, but one is much easier for a passenger to understand. Fourth, safety. What happens when someone asks something the chatbot shouldn't do? For example, tell me another passenger's booking details. The chatbot shouldn't make something up just to be helpful, so we deliberately test these situations before real passengers do. And finally, operations. Is the application fast and affordable enough to actually use? If every answer takes 40 seconds, passengers aren't going to wait at the gate. So level 3 asks the simplest question: would we trust this application with real passengers? So now you have an eval suite. The structure is components, pipeline, application. First test the pieces, then test them together, then judge the final thing. But you are going to make changes in the system like chunk sizes, prompt, AI model, etc. to improve your evaluation scores. You need to track these evaluations over time because you're going to change your system. Maybe you change the chunk size, then you run the same 50 questions again. Now you can compare before, recall 82%, after, recall 89%, great. But maybe precision, changed from 78% to 71%. Latency became 1.8 seconds from 1.2 seconds. Now you can see exactly what your change did. That's regression testing. You keep the same evaluation set and run it every time you change the system. The results are logged so you can compare one version against another. Tools like Langsmith or MLflow can help you log these runs and track your metrics. And this is important because otherwise, 3 weeks later, you won't remember. Was version 7 actually better than version 6? The tracking tells you that. So the workflow becomes change something, run evals, log results, compare, decide. That's how you stop guessing whether your RAG system got better. You have evidence. So far, we've been testing the chatbot before putting it in front of the passengers. But once the chatbot goes live, something changes. Passengers will ask questions you never thought of. Something like, can I bring my peacock on the flight? So you can't have a perfect answer key for every question anymore. Instead, you watch what happens in real conversations. For example, a passenger asks, my flight was canceled because of a storm. Will the airline pay for my hotel? You never added this question to your test set. The chatbot gives an answer. Now you can still check some things automatically in production. Was the answer based on the information it retrieved? That's faithfulness. Did the answer actually answer the passenger's question? That's answer relevance. But you can't automatically know whether the answer is actually correct without knowing the correct answer. So for real traffic, you also track things like, did the passenger give it a thumbs up or thumbs down? Did they ask the same question again? Did they give up and call the airline instead? These signals help you find where the chatbot is failing, and you don't need to run expensive LLM evaluations on every conversation. You can sample a small percentage of real conversations and evaluate those more deeply. Now here's where it gets interesting. Your live application is generating new test cases for you. The passenger asks, will the airline pay for my hotel? The chatbot gets it wrong. The passenger gives a thumbs down. That's not just a bad conversation, that's a new test case. You find the correct answer and add that question and answer to your golden set. Next time you change your RAG system, you test it again. So the loop is real passenger, failure, new test case, fix, evaluate, deploy, real passenger. Your real users show you what you missed, and every important failure becomes a test that protects you from making the same mistake again. So step back and look at the whole thing. We measured recall, precision, faithfulness, relevance, correctness, safety, speed, and cost. It sounds like a lot, but underneath we're asking a few simple questions. Did we find the right information? Did the model use it correctly? And can we trust it in the real world? And if you can explain this entire evaluation process clearly in an interview, you're not just throwing around words like RAG, recall, and faithfulness. You're showing that you understand how to tell if an AI application actually works. Honestly, give an interviewer this answer confidently, and you might just walk out with an offer letter. Eval exists so you can change your system without guessing. Change the model, change the prompt, change the chunks. And your evals tell you what got better, what got worse, what did you break. Without evals, every change is, yeah, it feels better. With evals, it's, here's what actually changed. That's the point of evals. and I've added my notes website link in the description where you can access the notes for this video. If this helped, like the video, subscribe, and follow for the next episode.